adsorption at liquid interface. So what is adsorption at liquid interface is, if you take a liquid water, we have water molecules at the surface. If you zoom, you will get this type, water molecules at the surface. We have a substrate called surfactant. Okay, surfactant has hydrophilic head and hydrophobic tail. Sir, why it is like that? Sulfate, lauryl, sodium. Okay, hydrophilic head and hydrophobic tail. Okay, surfactants. What is another name I can give to this? It's liking water and also it is heating water. What can I name it? Amphiphile. It is liking both. It is liking lipophilic and it is hydrophilic. So we can also call it as amphiphilic. Okay, amphibian means what? Both water and land. Like that we can name it as amphiphilic. That what is surfactant. When you add surfactant in water, surfactant will adsorb at the liquid interface. Surfactant will adsorb at the liquid interface. How it will adsorb? It will sit between the water molecules. Now, between the water molecules, we have cohesive force. Due to this only, there is surface tension. If anybody is sitting in between, obviously the cohesive force will decrease. The cohesive force will decrease and there is decrease in surface tension. So, you drew the graph. Initially, we have 72.8 surface tension. Added surfactant, decrease 1%. Okay. Then added surfactant, decrease 2%. Then added surfactant, decrease 3%. At some percentage, there is no place for surfactant to adsorb at the liquid interface. At surface, there is no space. See, there is no space. Now, what it will do? See, if you go to America, people will form association. Telugu association, Tamil association, Indian association. This will also form an association. Okay, this will also form an association. How they will form association? They want to protect their tail. Tail is hydrophilic. They will put the tail inside and they will orient and form an association. Okay, they form an association. That association is called what? Micelli or micelle. Okay, micelli or micelle, which has an hydrophobic pocket, where if your drug is insoluble, you can make the drug to sit in the hydrophobic pocket and solubilize. You can make the drug to sit in the hydrophobic pocket and solubilize. Okay. Reverse. If you take lipid phase, if you add surfactant, the association will be reverse. The association will be reverse in other side. It will associate in other side. How it will associate? Like this. This is how they will associate in the lipid phase. Okay. So at particular after one concentration, if you add any surfactant, it will directly go into the bulk of the solution by forming association. So initially they will decrease the surface tension. At particular concentration, they won't decrease the surface tension because they are not sitting at the surface. They are going into the bulk. They are not at all sitting at the surface, they are going into the bulk. So that is the reason initially you will get decrease in surface tension. After particular concentration, even though you increase the concentration, surface tension will remain almost constant. It will remain almost constant. The concentration from where the surface tension is remaining constant is called as CMC. Who is today's batch? Listen. This what the adsorption at liquid interface. Okay. So when you add a surface active agent, initially it will decrease the surface tension by adsorbing at liquid interface. At particular concentration, they will go into the bulk of the solution. They will go into the bulk of the solution. There, from that concentration, they are not able to decrease surface tension because they are not able to adsorb at the surface. They are going into the bulk. So the concentration from where it is going into the bulk is called as critical micellar concentration. From that concentration, it is forming micelle. That's what it is. From that concentration, it is forming micelle. Okay, this what is adsorption at liquid interface. Because we are studying about surfactant, in the same topic we study about surfactants. Like your pH scale, surfactants are also classified on one scale. That scale, what can you name that scale? It is named on the chemical composition of surfactant. Okay, what is this? This? Name it. Name the scale. Hydrophobic, hydrophobic, hydrophilic, philic scale. This is your nomenclature. What scientists named it is hydrophilic, lipophilic. They want only loving. So they said hydrophilic, lipophilic balance. Okay, you need to balance it. Hydrophilic and lipophilic balance. HLB scale. It is an arbitrary scale. What do you mean by arbitrary? What do you mean by arbitrary? No units. Nothing will be there. It's just an arbitrary scale. Starts from 1 AR, not OR. OR means this orbit. AR, arbitrary. Okay, starts with 0 or 1. It will go till 40 also, but for time we will consider 20. Okay, so here we have numbers. Depending on where it is falling, just we'll see. What could be the less number represent? Hydrophilic or lipophilic? Guess it. You guess it. What could it be? Whether it is lipophilic or hydrophilic? No, it is lipophilic. Less number indicates lipophilic, higher the number indicates hydrophilic. As HLB number increases, I will tell you why. There is a calculation for HLB. There is a methods to calculate, 3 methods are there. In that method, we consider the groups. So there we consider hydrophilic group more. Hence, more the number, more will be the hydrophilicity. Less the number, more will be the lipophilicity. Tell in philic only, in loving only. Don't tell in hating. Okay. Lesser the number, more will be the lipophilicity. Higher the number, more will be the hydrophilicity. Now surfactants will fall here. Depending on what is its HLB value, surfactants are classified as anti-foaming agents. Surfactant classified as detergents. Okay. Surfactants are classified as oil in water emulsifying agents. Surfactant is classified as water in oil emulsifying agents. Now you tell me, we have two. Before I explain this, you only tell me. You know the basics. Lower the number, surfactant will love oil more. Higher the number, surfactant will love water more. I want to prepare 2 emulsions. Now, for oil in water, higher number or lower number? If you say high, why? If you say low, why? 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 more quantity water should be there, hence you need hydrophilic more. So you want more HLB number to prepare oil in water emulsion. Very good, you got it. Okay, water in oil is more, hence you want lipophilic should be more. So this will fall here. HLB is a scale, write down 1 to 3. HLB 1 to 3 is anti-foaming agents. HLB 1 to 3 is anti-foaming agents. Listen, you prepare a liquid formulation. In that formulation, we say shake before use. When you are shaking, foam is forming. To avoid that, you can add this anti-foaming agents. Next, 3 to 8 oil in water emulsifying agents. 3 to 8 oil in water emulsifying agents. Then 7 to 9 wetting and spreading agents. We just spoke, if you want to increase the spreading of your ointment, use surfactant. So this is what the surfactant you should use, 79, to increase the spreading of your ointment. Wetting and spreading agents. Then 8 to 16. 8 to 16. See, this one is water in oil. I said oil in water. This one is water in oil. Okay, this one is water in oil. Next, 8 to 16 is oil in water. Your below one is water in oil. 8 to 16 is textbook. There is a printing mistake. That's why I did mistake here. It is written both oil in water. Textbook printing mistake is there. Note down it. Okay. 8 to 16 is oil in water. 3 to 8 is water in oil. Then 13 to 16 detergents. 13 to 16 is detergents. 16 and above. 16 and above is solubilizing agents. If your drug is not soluble, in that case you need to use an HLB of this one, 16 and above, solubilizing agents. So depending on the HLB, this how the surfactants are classified. There is no value here. There is no value. It is arbitrary. Just vague number is given. So depending on the number, we classify that surfactants. Okay, sir, you classified, you told the number. Now somebody gave me surfactant. How should I find? I don't know its HLB value. How should I find HLB value? Next, determination of HLB. Methods for estimation of HLB. ఏం చేస్తున్నారా? నువ్వు 2xలో ఏమని చేశా? Okay. Methods to determine HLB. First method, there are 3 methods. Okay. Method 1. Method 1. What could be the method 1? See, depending on the chemical nature and groups only we divide this. So what should be the first method? It has which groups? Polar and non-polar. What that group name is? Polar group is what? Correct. Hydrophilic. Non-polar group is hydrophobic. Same in philic only. Lipophilic. Now, this is the first method. because there are three methods, you will confuse what to write in method. So first method is taking their group number. Okay, write down. Method 1, chemical structure of a molecule is split into different component groups. Chemical structure of a molecule is split into different component groups. Different components groups, full stop. Each group is assigned a number. Each group is assigned a number. Hydrophilic group is assigned one number and lipophilic group is assigned a number. Now, how many hydrophilic groups are there? You need to sum it. How many lipophilic groups are there? You need to sum it. Write down. Full stop. Sum of these numbers is calculation of HLB. Sum of these numbers is calculation of HLB. Is calculation of HLB. You write down HLB is equal to formula. HLB is equal to, say like this. HLB is equal to summation of hydrophilic groups minus summation of what? Lipophilic group. Summation of hydrophilic group minus summation of lipophilic group plus 7. At last it is plus 7. See, in the formula you can see hydrophilic group is at first. If HLB value is more, hydrophilic group should be more. Okay, see, if I say A minus B is equal to Z, Z value is more when this is more and this is less. So, hydrophilic and lipophilic, obviously more HLB value indicates more hydrophilic groups. Okay, write example. SLS. Example is SLS. Now you need to calculate, use this formula and calculate it. Okay, I will tell you what SLS contains. SLS contains Lauryl group, means what? 12 carbon chain. 1, 2, 12 carbon chain and sulfate and sodium. Sodium lauryl sulfate. Okay, this is what it contains. See, what is the hydrophilic group here? This is hydrophilic group. I will give a number to this, that is 38.7. Hydrophilic group number is 38.7. Lipophilic group, what is the lipophilic group? CH3 and CH2. For this I will give a number of 0.475. Same number for CH2 also, 0.475. You calculate. How will you calculate? HLB is equal to sum of hydrophilic. How many hydrophilic groups are there? Only one. So you write this number 38.7 minus how many lipophilic groups are there? 11. See, CH3 one number is there. CH2 same number is there. But total how many are there? 11 plus 1, 12. So 12 into 0.475. So 38.7 minus 12 into 0.47. What is it? 475 plus 7. You do it, you get 40 as a HLB. What is 40 indicates? Which agent it is? Solubilizing. Above 18 or 16 is solubilizing agent. So your SLS is a solubilizing agent. Do the calculation, check how much you will get. So anything above 16 is solubilizing agent. Now you can ask question, sir, you said only 20 scale, why you are saying 40? I told you it is going above, but for time being we will consider, because Anything above 16 is solubilizing agent, so no need of writing there 40, 50, 60. Instead you write 20 or 18, that's all. You got why I am taken 20 here end point? That is the reason. I could take 16 also. 16 should be the end point because above 16 is solubilizing agents. Scale starts from 0. Remember, I said 1. It's not 1. Yeah, I written 0. Yeah, scale starts from 0. So method 1, quick. When you go to method 2, I want to complete this. Method 2, each atom. So I should make you to tell. Now we took the group. Next method, we'll enter into the atom. We enter into the atom, assign a number to the atom, then we'll calculate. Okay. Each atom or group has been assigned a number. Each atom or group has been assigned a number. Example, if surfactant contains polyoxyethylene chain, if surfactant contains polyoxyethylene chains, then HLB value can be estimated by, remember this method is only useful to a surfactant which contains polyoxyethylene chain. HLB is equal to E plus P by 5. HLB is equal to E plus P by 5. What is E? I said polyoxyethylene. That should be ERP. P is polyoxy, E is ethylene. Right on. E is percentage weight of ethylene oxide chains. E is percentage weight of ethylene oxide chains. And P is percentage weight of polyhydric alcohol. And P is percentage weight of polyhydric alcohol. So for method 1, example is SLS HLB is measured by method 1. Method 2, beeswax and lanolin. GPAT question. Beeswax, B, honeybee. Beeswax and lanolin derivatives. Beeswax and lanolin derivatives can be estimated by method 2. So in method 2, what are the things which can be estimated is this one, beeswax and lanolin. Method 3. Method 3. See, if surfactant contains fatty acids, in that case, what could be the method? Guess it. How you measure fatty acid? Go to chemistry, you have done this. Acid value. Saponification. That's all. Saponification and acid value. This is what we have to take. Write down. If surfactant contains ester functional groups. If surfactant contains ester functional group. Fatty acid is a ester, remember. Okay. Surfactant contains ester functional groups such as glyceryl monostearate. GPAT question. Glyceryl monostearate is estimated by method 3. HLB can be determined by following equation. HLB is equal to 20 into 1 minus S by A. We have experiment for this. I don't know whether you people have or not, but we did the experiment for this. We took one surfactant of ester, then we found out its acid value and saponification value, and we calculated HLB. Just substitute saponification value here and substitute acid value. You will get HLB value. Okay, I will tell you one thing. Right on. Okay, I forgot the main thing. There are two main surfactants which will you hear from now. Spans and twins. We are going to listen this. What are spans? Are sorbiton esters. Spans are sorbiton esters. Twins are polyoxyethylene sorbiton ester. Both are sorbiton esters. Twins have polyoxyethylene group in them. Span don't have polyoxyethylene group in them. Now tell me, use your knowledge and tell me which is lipophilic, which is hydrophilic. Why? Very good. Spans are lipophilic because we have oxy group. It is more hydrophilic. Twins are hydrophilic. Very good. Write down. Spans have a value of 1.8 to 8.6. Write down. Spans have a HLB value of 1.8 to 8.6. 1.8 to 8.6. Spans has a value of 1.8 to 8.6. And twins has a value of 9.6 to 16.7. Twins has a value of 9.6 to 16.7. Okay, over. You write. I will give one twin number, one twin saponification acid. You tell me what is its HLB. Write down. Twin 80. The twin, see, we have twin 20, twin 30, twin 40, twin 80 like this. Okay, as the number increases, its hydrophilicity also increases. Twin 80, saponification value is 47.5 and acid value is 190. I will finish the class here. You calculate and tell me what is it.